Alright, so today I'm going to start on my next project. This is a board I bought, I believe, on eBay, probably a couple years ago. It's been a while. And it's a Video Pinball by Atari. I used to have one of those machines, and it was great, and I loaned it out to somebody for them to run it on location, and it got stolen. And I really regretted that. That was really a game I wanted to keep. But anyway, I bought this board on eBay or whatever, and just looked at it, really looked at it for the first time, because I want to start working on it. And I noticed missing 2 PROMs. Okay, according to the schematics, all these PROMs should be populated for version 1 of the firmware. And also missing 2 PROMs here. And these PROMs store graphics data for the video out. So I don't want to program these old PROMs, and probably if I tested these, more than one is going to be bad. I mean, those things are notorious for going bad. So I want to engineer around that. I used the PCBWAY company in China to build a couple of boards. This one here will be a board I stick there to replace all these PROMs. It'll be just a single EPROM, a 2764 EPROM. That's all it needs to hold that. I think it's 4K total memory. And then also for this guy, I made a board that's going to plug into those 2 locations and replace the 2 PROMs here with a single high-speed EPROM or EEPROM. These outputs, these video output PROMs have to be high speed, or the graphics will get screwed up. So that's why I created a board to use a high-speed double EPROM. The other option would be to just socket these guys and put the original PROMs in there, because the PROMs, the reason they used PROMs back in the day was they were very fast. Access times in the 50 nanosecond area. So I think the EPROM I have is 90 nanoseconds. I think it's going to be fast enough, but we will see after we build it. I'm hoping it is. Anyway, so this is the first video. I've already built a test harness for it, so I'm going to get that plugged in and get these boards populated and plug them in and see where we're at. So I built this one first, the video output PROM replacement chip circuit board. And before I built this, I was getting no video at all because, I mean, there was no video being generated and pushed to the output. Now we've got video. So progress is being made. Of course it doesn't run. I'm missing 2 PROMs. And the PROMs that I have are probably bad. I have not tried self-test. Let's see what self-test does. Nothing. But this is a good test. I'm seeing letters. I'm seeing the ball shape. I'm seeing bits and pieces of graphics. It looks like the PROM that I put in, which is a W. It's a wind bond high-speed EPROM. It's a 45 nanosecond access time, which should be blazingly fast. I mean, fast enough for this application. So, yes, this is going to work. In fact, this piece of the circuit is working. And what I did was I installed 2 sockets and just jammed this into it. Not the best fit, but it's adequate. It'll get the job done, and it fits in there super tight. All right, so I don't know if the problems are the program ROMs. I'm just missing 2 of them. If that's what the problem is, where I'm not getting any, gameplay, I suspect it is. Could be the processor. Actually, no. This is a new processor. I put a new NOS one, an NOE, new original equipment one. So power looks good. Clock signals look good. Video output now looks good. So I'm going to focus on getting the ROM, the game ROMs, where it's using my chip, or my PCB. I'll populate that. I'll slap it in here, and with the program, I've already gotten the program ROM burned. This was created with a code that I wrote a program for to generate. It takes all the ROM codes that I got out of MAME and combines them such that this ROM here, that this code's in this ROM, should run the program using my board. Well, that's the next step. Okay, so I got my little CPU ROM Unirom PCB installed and built up and installed, I should say. And I got my video output PCB installed, and I've removed all the original PROMs. So those are sitting right there. So ready to turn it on and see what happens. Let's see. All right, no smoke. No smoke. Oh, we got something happening, but it's not quite right. But apparently the game is running. Or the program is running. Got some garbage here. Not sure what that is. Looks like it's flashing the score. Got the flippers there. Got, I guess that's ball 1 there. Not sure. I think those are going to be the drop targets. And we've got some miscellaneous garbage here. Not sure what that is. So basically this whole line of video here is bad. It's got 2 flippers there. So this is looking promising. I must have a bad RAM. Let me flip it into self-test. So I don't know what to expect. I've got the schematics here, but I don't think I have the test instructions. This is just the schematics. So anyway, I don't know. I've got a speaker here. I didn't hear anything, but I'm not going to hear anything because I'm missing the volume control pot. I think that's a 50K. I need to look that up in the schematic. It's either a 5K or a 50K. So I'm not going to have the exact one because it was an oddball one. Maybe if I throw in a 10K or something, that will be good enough. Let me grab something and throw it in and see if we can get some audio results on the self-test. Okay, so this volume control pot was supposed to be a 50K, and I didn't have that. So the closest thing I had was a 20K. I put a 20K in there. Still didn't get any audio, though, when I tested. So I probed around. This right here is supposed to be an LM380 equivalent audio amp. And I'm probing around, and I'm getting no 18 volts here. So I used the 12 volts. I connected my 12 volts from the power supply here to supply the power for the regulator. And so I need to jumper a wire over to get power over to these diodes right here. That's what's going to supply the 18 volts, or in this case 12 volts, to power this. Hopefully this thing will work on 12 volts. I haven't looked at the spec. I'm just going to blindly hook it up and hope for the best. So that's what I'm going to do next, so I can get some power to this and see if we get some audio. Okay, so I rerouted one of my 12 volt lines over to the input power for the audio circuit. And let's give it a shot. Okay, getting some beeping. So that's when I flip the self-test, the beep start. That's probably a RAM error of some type. So let me do the test one more time. Oh, one thing about my board, if you hit the reset button, that light lights up. That gives you a kind of a diagnostic helper there. So if you're in constant reset, that light will flash constantly. So let's do that. Let's count the beeps. Yeah, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. So 8 beeps, and the third beep was bad. Okay, let me look it up in the manual. Okay, I looked up the RAM error in the manual online for Video Pinball, and the 8 beeps represent the data bit 0 through 7 apparently. So data bit 2 is bad. That doesn't tell you which RAM's bad. It's going to be one of these 4 here. Before I start removing anything, I'm going to visually inspect the board, make sure I don't have a short somewhere, like one of these caps legs touching or something, and or an open trace. And if I don't find anything hinky, I'll put a probe to it and see if I can see a bad signal. But it's not going to tell me which RAM it is. It's going to tell me it's going to tell me which one of two, not one of four. It's going to eliminate two of them. The RAMs are in upper nibble and lower nibble. In other words, two chips have 0 through 3 data bits, and the other two have 4 through 7. So I'll look at the schematic and figure out which two is for 0 through 3, because the arrows are indicating D2, and focus on those, remove those two carefully. 2114 RAMs are getting kind of hard to come by. So that's where we're at. I'm gonna see if I can figure out the problem, and then I'll be back. Okay, I got a piece of ice here. I got the game on. Since it's kind of acting up already, there's no reason to let it heat up, although you might do that. It might give you better results. So I'm going to put the ice cube on top of the first one. We'll start with this one. That's the first one we'll start with. Let's see if that makes any difference after I get it on there. I don't expect it to miraculously work from this, but I do expect to see a change in that unstable graphics if this chip is affected by the temperature. Not seeing anything. Not seeing any change. Alright, I think that would be enough to get it. So let's go to the next one. This one's F3. Leave it on there for about a minute, I guess. Give it a chance to get down to where the die is. Not seeing any difference. I don't know. Maybe that's a difference. Yeah, I think I'm inclined to replace this one. Let me go back to the other one. See if I can. Oh. Okay, and that just may be the water dripping down on it. Dry it off. Try that again. All right, this one is E3. I am seeing a slight difference. Try F3. Again, F3 seems to give a slightly different, more dramatic change. So I'm inclined to think that F3 is the one I'm going to try first. All right, yeah, I'm going to go with F3. It looks like the graphics are a little bit wackier when I cool it down. A little bit different. Anyway, that's about all you can do with this stuff. I mean, the self-test isn't accurate enough to tell us what the problem is. It should be, but they didn't program it right. All right, well, let me try replacing F3 first and see what happens. Well, I replaced that chip, and it didn't change anything. So there's only two things it can be at this point. It can be the other one of these RAMs, which would be the E3 RAM, or it could be this transceiver. Don't know why it would be that, but it could be a weird error in that. I guess the logical thing is try to replace E3 next and give it another shot. Well, good news. I went ahead and chopped out the other RAM right here, the one that was in E3. That was actually the bad one. Chopped it out and put a socket in its place. I put the RAM that was here in F3. I put it in E3, and then I had a spare for F3, or a spare RAM, and I put it in F3. And working all the way. Looks like it's working perfect. Put it in self-test. No beeps. Comes up into the test pattern. Everything seems to be working, but hell, what do I know? I've never had one of these on my bench before. I've had it in a game before, but I do believe we're working. Now, this is on free play, apparently, so I need to figure out how to change that on these dip switch settings, I guess. But that's it. Built a board to replace all the PROMs. Built a board to replace the 2 video output PROMs, and it had a bad RAM. And really, this went better than expected. I'm not done with this project, though. I want to build a board to test the lights, because this thing, all these transistors here that you see right here, that array of transistors controls lights on the playfield. And so I'm going to build a test board for that and add it to my test fixture. But that'll be a separate video. Well, that's it for this one. The board's up and running, and if anyone has one of these games and needs a board like this repaired, or you want to replace all the PROMs with one of my Uniprom or Unirom PCBs, or if you want to get rid of those antiquated PROMs and put one of these video output PROM replacement PCBs, you can reach out to me. I can set up a kit or something. Well, that's it for this one. Thanks for watching.